The next question is, the circumference of a circle exceeds the diameter by 16.8 centimeter. Find the radius of the circle. In this question, it is given that the circumference exceeds the diameter by 16.8. As we know, the circumference of a circle is 2 pi r, and the diameter is represented as twice the radius, and the difference between the circumference and the diameter is 16.8. That is, circumference minus diameter is equals to 16.8. By taking 2r as common, we get pi minus 1, which is 16.8. By putting the value of pi, that is 22 upon 7 minus 1, is equals to 16.8. By taking the LCM 7, we get 22 minus 7, which is 16.8. 2r, 22 minus 7, that is 15 upon 7, is equals to 16.8. So by shifting 16.8, we get 7 upon 15. 15 by 7. As we shift this to the right hand side, the 15 by 7 becomes 7 by 15, and the 2 becomes 1 by 2. On solving this, we get the value of radius is 3.92 centimeter. So according to option A is correct. The area of two circles are in the ratio 16:25. Then find the ratio of their circumference. In this question, we have given the area of the two circles. Let the areas are A1 upon A2. As we know that the area is pi r square, let's say pi r1 square. The area of circle 2 is pi r2 square, which is given in the question as 16 upon 25. We can cancel pi, so we get r1 upon r2 the whole square is equals to 16 is the square of 4 and 25 is the square of 5. It can be written as 4 by 5 the whole square. By comparing these two sides, we get the value of r1 upon r2, which is 4 by 5. Now we find the ratio of their circumference, that is c1 upon c2. The formula for the circumference is 2 pi r, that is 2 pi r1 upon 2 pi r2. As we see that the 2 pi is common in both numerator and denominator, we can cancel 2 pi and we get r1 upon r2. The ratio of the circumference is equals to the ratio of radius, that is to be 4 by 5. So according to option A is correct. Now we move to the next question. Two circles seen in the figures are concentric. Chord AB of the larger circle is tangent to the smaller circle and its length is equals to the 16 units. The area of the shaded region is. So in this question we have given two concentric circles, the first circle and the other circle, and there is a chord AB which is work as a chord for the bigger circle and the tangent for the inner circle. Let the center of these two circles be O and the point of contact as C. Now when we join center to the point of contact, we get the radius for the smaller circle, let's say r, and when we join the center to the point B, we get the radius of the bigger circle, that is, it is represented as capital R. And we know that when we drop perpendicular from center to the chord, it will bisect the chord, that is AC equals to BC. AC equals to BC, or we can say the BC is half of AB. As the length of AB is 16 unit, so BC is half of 16, that is 8 unit. So the BC is of 8 unit. Now in triangle OCB, by applying the Pythagoras theorem, we get r square is equals to small r square plus 8 square, or we can get r square by shifting r square small r square to the left hand side. R square minus small r square is equals to 64. By multiplying both the sides by pi, capital R square minus r square is equals to 64 pi. The pi capital R square minus small r square gives the region of the shaded area. So according to option B is correct. Now we move to the next question. In this question, if AC passed through the center of the circle, then the area of the shaded region in the given figure is. Here AC is passed through the center, so AC is work as a diameter for the circle. Now, and we know that the angle made in semicircle is always 90 degree. So this angle B is 90 degree. Now by applying the Pythagoras theorem in triangle ABC, we get AC is equals to under root of AB square plus BC square, which is to be under root of A square plus A square, that is A square plus A square, that is 2A square. The under root of 2A square comes to be root 2A, or as we know that the AC is the diameter, so the radius of the circle is diameter half, that is root 2A divided by 2. Now we can find the area of the shaded portion by subtracting the area of triangle from the semicircle ABC. We can find the area of the shaded portion by subtracting the area of triangle ABC from the semicircle ABC. So the shaded area is equals to the area of the semicircle, that is pi r square, that is root 2A by 2 the whole square half. This is the area of semicircle, that is pi r square divided by 2 minus area of the triangle ABC. Area of triangle ABC, that is half the multiplication of the two sides which are making the right angle, that is A and A, that is A into A. Now that is pi by 2 root 2A by 2 the whole square comes to be 2A square by 4 minus A square by 2. By taking here 2 is cancelled by 2. Now by taking A square by 2, we get pi by 2 minus 1. So according to option D is correct. In this question we have given three circles, each of radius 3 cm, which are touching externally, and we have to find the area of this shaded portion. Let the center of the three circles are A, B and C. Now we join these three centers by straight lines. So the distance, this is the radius, and this distance is also the radius. The distance, this is also a radius. 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 So we seen that the triangle ABC is an equilateral triangle because all the sides are of 2r units. R plus R, that is 2r. AB is 2r units. BC, that is R plus R, again 2r. And the side AC, R plus R, again 2r. So the triangle ABC is equilateral triangle with side 2r, that is 2 into 3, that is 6 cm. Now we can find the area of triangle ABC. We know that the area of equilateral triangle is root 3 by 4 side square. the side is 6, that is root 3 by 4. 6 square is 36, that is comes to be 9 root 3 centimeter square. Now we can find the area of this shaded portion by subtracting the three sectors from the area of triangle ABC. So as we know that it is an equilateral triangle, so the angle made at the center is 60 degree, because in equilateral triangle each angle is of 60 degree. So we can find the area of these three sectors by using the area of sector, that is the area of three sector is equals to 3 times the area of each sector, that is theta upon 360. Here the theta is 60 degree upon 360 into pi r square. Here the radius is 3 centimeter, that is pi r square. So by cutting 60 by 360 6 times, by cutting 3 to the 6 2 times, we get 9 pi by 2. That is the area of the three sectors, that is 9 pi by 2 centimeter square. So the area of shaded portion is equals to area of triangle minus area of three sectors. The area of triangle is 9 root 3 minus area of sector, that is 9 pi by 2. By taking 9 by 2 common, we get 2 root 3 minus pi centimeter square. So according to option, the option B is correct.